Hello everyone. In this video, we are going to learn about a subject called electrical measurements and instrumentation, which is considered as EM and I. First, we are going to know about the topics what we are going to discuss in this electrical measurements and instrumentation. I will give you a brief view about all the units and all the topics what we are going to discuss in this video. In the first unit, we are going to discuss about what are the different types of instruments we have and what are the different types of errors we have and how to extend the range of a meter, either it may be ammeter or voltmeter. And the last topic what we are going to discuss in unit number 1 is regarding electrostatic voltmeter. And coming to the unit 2, the topics what we are going to discuss in this unit is regarding potentiometer, how to standardize a potentiometer, what are the applications of potentiometer and what are the types of potentiometers we have. Either it may be DC type or it may be AC type potentiometer. And the last topic what is present in unit number 2 is regarding instrument transformers. What are the types of instrument transformers we have and what are the different applications of CT and applications of CT, what is the ratio and phase angle error. These are the topics what we are going to discuss in unit number 2. Coming to the unit number 3, we are going to discuss about construction and working of a electrodynamometer wattmeter and also construction and working of a single phase energy meter along with the expressions for the derived driving torque, braking torque and also its applications, advantages, disadvantages, everything regarding wattmeter and also energy meter in unit number 3. Coming to the unit number 4, we are going to discuss about different types of bridges which are used to measure resistance, inductance and capacitance. Resistance, inductance and capacitance, all types of DC bridges and AC bridges which are used for measuring these parameters are going to discuss in unit number 4. Coming to the unit number 5, in this unit we are going to discuss about electronic instrument, that is a particular type of instrument called transducer. What are the different types of transducers we have? What is the general wave? What is the LVDT? What is piezoelectric transducer? Photoelectric cell? Working and operation of all these different types of transducers are explained in unit number 5. And also regarding a small discussion regarding CRT and CRO in unit number 5. Now we will enter into the topics what is present in unit number 1 of electrical measurements and instrumentation subject. The first topic what we are going to discuss in unit number 1 is regarding types of forces acting upon instrument. Types of forces acting upon instrument, either it may be any instrument, either it may be an ammeter or voltmeter or wattmeter. How these three forces will play a major role in getting a reading of ammeter or voltmeter or wattmeter. So to explain this content, that is types of forces, I am going to take an example of voltmeter. I am going to take an example of voltmeter. Let me say that the range of the voltmeter what I am considering to measure is taken as 10 volts. That is 0 to 10 volts voltmeter, where the range of this voltmeter is taken as, the minimum value is taken as 0 and the maximum value is taken as 10. The minimum value is taken as 0 and the maximum value is taken as 10. By using this voltmeter, I want to measure the voltage as 5 volts. I want to measure the voltage as 5 volts. Now, how the different types of forces will act upon this voltmeter to give the reading as 5 volts is my topic. Now, there will be 3 types of forces acting upon every instrument to measure this particular value. The 3 forces are, the first force is deflecting force, and the second force is controlling force, and the third force is damping force, and the third force is damping force. So by using these 3 types of forces on a particular instrument, I am going to take a reading, either it may be in terms of current or it may be in terms of voltage or it may be in terms of power. Now I have considered an example as well 5 volts. Before going to discuss about these topics, let us have an example. Suppose let me say that this chalk is an object. Now if I want to move this object from one point to another point, I need to apply an external force to this. I need to apply an external force to this. Similarly, I have taken an voltmeter here. Let me say that it consists of a pointer. As I have considered earlier, what is the range? The range of voltmeter is taken as 10 volts. The maximum value is 10, the minimum value is 0. Now what is my condition? By using this voltmeter, I need to take the reading only as how much volt? 5 volt. That is, my pointer should stop at 5. My pointer should stop at 5. Now the pointer is my object. Now the pointer is my object. You see here, for a voltmeter or ammeter in an experiment, I am not applying any force externally here. I am not applying force on the pointer to move from 0 to 5 to take the reading as 5 and at 6 or 7 or 8 continuously. So internally, some current or voltage parameters are converted into force, and that force is utilized to move the pointer here. Why? Because I am not applying any force to the instrument directly. I will pass some amount of current with the help of two wires in any experiment. But the current is not the parameter which is used to move the pointer. That is, according to physics law, I need to apply an external force to move an object from its initial position. So these are the three forces what I am going to use in this instrument to take the reading as 5 volts here. Now coming to the first one, that is deflection force. The force which is required to move the pointer from its initial position or starting position. The force which is required to move the pointer from its initial position or starting position is called as deflection force. That is, the force required to move the pointer from its zero position is called as what? Deflection force. The first thing is how the force has been applied in this particular voltmeter here. I am giving the input parameter as voltage, or else I am applying some amount of voltage or current to this particular meter. How this current has been converted into force here? By using the magnetic effect, or else by using the thermal effect, or else by using any other effects. You can convert the input parameter current into the force by using any one of the effects what we are going to discuss here, either by using a magnetic effect, or by using a thermal effect, or by using inductance effect or mutual conductance. By using any effect, you can convert this internal parameter current into force here. The force which is required to move the pointer from its initial position is called as deflection force, where the deflection force can be achieved by using a magnetic effect or thermal effect or inductance effect or else any other thing. Coming to the next one, controlling force. What is my aim? My aim is to take the reading of voltmeter as 5 volts. Take the reading of voltmeter as 5 volts. I am applying the force in this direction. If I apply the force in this direction, what happens is nothing but the pointer directly moves to the 10 volts. Why? Because it doesn't have any opposing force here. That is the reason I am applying the control force in opposite direction. Now what I will do is nothing but, as the deflection force is applied in this direction, I will apply the controlling force in opposite direction to that. So what is the main reason of applying controlling force? The force which is required to oppose the position of a pointer is called as what? Control. That is, it mainly controls the position of a pointer. By applying two forces in opposite direction, I am applying deflection force in this direction and controlling force in this direction. What happens? The two forces will collide at a particular point. Two forces will collide at a particular point. Due to that reason, the pointer will start oscillating. Why? Because according to the law of physics, when two objects collide with each other, what happens? Some amount of collisions will take place. So in order to take the accurate reading as 5 volts, I need to reduce that oscillations. So to reduce that oscillations, I am going to use one more type of force, that is called as damping force. The deflecting force is used to move the pointer. The controlling force is used to control the position of a pointer, and the damping force is used to reduce the oscillation of a pointer. By using these three forces on a particular instrument, I am going to take the accurate reading as 5 volts. The same case can be considered in case of an ammeter, or else in case of wattmeter, or else in case of any other meter which consists of an object called pointer. This is regarding brief discussion how an instrument will work based upon the three forces. Now I am giving you a brief definitions about deflecting force and controlling force and damping force here. The force which is required to move the pointer from its initial position is called as deflection force, where the deflection force can be achieved by using magnetic effect, thermal effect, inductance effect and etc. Controlling force. The force which is required to control the position of a pointer is called as controlling force, and this controlling force can be achieved by using two techniques. One is nothing but spring control method and another is nothing but gravity control method. So the controlling force can be achieved by using these two techniques. And coming to the last one, the force which is required to reduce the number of oscillations in a pointer is called as damping force, and the damping force can be achieved by using eddy currents, air friction, and the last one is fluid friction. And the last one is fluid friction. These are the three types of forces which will play a major role in getting a reading of an instrument. Now we will discuss about what are the different types of errors and what is an error present within an instrument. Before going to discuss about the types of errors, we will have a definition of an error. We will have a definition of an error. Before going to discuss about error, I want to give an example. First, I have taken a voltmeter. The range of the voltmeter is 5 volts. The range of the voltmeter is 5 volts. At the starting, when I performed the experiment by using this voltmeter, the reading what I got from the voltmeter is 5 volts. Okay. I have used the same voltmeter for the another experiments. I am getting the reading as only 4.99. Similarly, when I am using the same voltmeter after 2 years or 3 years, I am getting the reading as 4.98. 4.98. As the reading of the voltmeter is taken as 5 volts, as I am performing the experiment for different times, I am getting a value of error as 0.02 for the third time and 0.01 for the second time. The 0.01 and 0.02 parameters are considered as errors here. So, error is defined as a difference between true value and measured value of an instrument, where true value is considered as the maximum value of the particular meter what I have taken, and the error value is considered as the 0.01. This 5 volts is considered as the true value of the instrument, and this 4.99 is considered as the measured value of an instrument. Now the error can be calculated as true value minus measured value. True value minus measured value. That is, the error can be defined as deviation or difference between true value of the instrument and measured value of an instrument. For example, the true value of the instrument is considered as 5 volts, as I have taken the range of the voltmeter as 5, and the measured value what I got from the voltmeter is 4.99. So 5 minus 4.99, which is equal to 0.01. The 0.01 value is considered as an error. The 0.01 is considered as an error here. The main definition of error is it is defined as deviation or difference between true value and measured value of any instrument. Either it may be ammeter, voltmeter, or wattmeter, or whatever it may be. Fine. Now there are different types of errors. Different types of errors. Coming to the classification of errors, errors has been classified into two types. Errors has been classified into three types. The first one is gross errors. Second one is systematic errors. And coming to the third classification of error is random errors. And the third classification of errors is random errors. Coming to the definition again, what is the definition of error? It is defined as difference or deviation between true value and measured value of an instrument. Coming to the classification, errors has been classified into how many types? Three types: gross error, systematic error, and random error. Now we will go about the definitions of a gross error and systematic error and random errors here. Coming to the first one, gross error. Gross errors are the errors which will mainly occur due to the human mistakes. Gross errors are the one which will mainly occur in the instrument due to the human mistakes. Due to the human mistakes. Human mistakes are nothing but in recording the values. In recording the values, or else in observing the values. In observing the values in the meter. What is gross error? It is an error which will occur in the instrument mainly due to the mistakes made by the human. Mistakes made by the human in recording the values or else in case of observing the values. Coming to the next type of error, that is called as systematic error. Systematic error. The name itself indicates that these are the errors which will occur mainly due to the manufacturing defect, or else in case of design and instrument, or else in case of errors which will cause it due to the observation, or else the errors which are caused due to the environmental conditions around that particular instrument. The errors which will be caused in the instrument due to the manufacturing defect or due to the design of an equipment are considered as systematic errors. I am going to give the definition for systematic error again. The errors which are caused in the instrument due to the manufacturing defect or design of the equipment are considered as systematic errors. The systematic errors are further classified into constructional errors. These are further classified into constructional errors, environmental errors, and the third one is observational errors. Constructional errors are nothing but when you are constructing an equipment, and let me consider that it is an ammeter. Due to the manufacturing defect, the ammeter is not able to read the value as 5 amps, as the range of that particular ammeter is 5 amps. So it has a manufacturing defect. So due to the manufacturing defect or due to the design, we are going to have a constructional error in case of an instrument. Coming to the next parameter, environmental error. The environmental error is nothing but the temperature, humidity and other environmental conditions will have a major impact in taking the reading by using any instrument. Whatever it may be the instrument, you take an instrument, an ammeter or voltmeter, the environmental parameters like temperature and humidity will play a major role, or else it will have a major impact in taking the reading by using that. Coming to the last one, observational error. So depending upon the position of the person who is taking the reading or else who is observing the values in a meter, you will get an error. This is the classification of a systematic errors. What are the types here? First one is constructional, second one is environmental, and the third one is observational error. Now coming to the next type, random errors. The name itself indicates that these random errors are mainly due to the noise and other effects which are caused. These are unintentional errors. Which are caused by the noise and also due to the other sound effects. So this is the classification of errors. Before going to conclude the topic, I am going to define the error again. It is given as a difference or deviation between the true value and measured value of a particular instrument. Coming to the classification, errors has been classified into 3 types: gross errors, systematic errors and random errors. Gross errors are mainly due to the human mistakes. Systematic errors are mainly due to the manufacturing errors or due to the design of an equipment, and random errors are mainly due to the noise and also the other sound effect which is created particular around the surroundings. These are the major types of